Good day, everyone. So welcome back to my YouTube channel. So guys, as I promised, I said I'm going to provide the part 2 video of this topic, which is the universal gravitational law. And then here I am. This is the part 2 where we have a look at the example, right? If you want to watch part 1, please go ahead and watch part 1. I'll leave a link under the comment section here. If you want to watch the part 1, just click the link to watch part 1. In part 1, we looked at the theory based on the universal gravitational law. That if you look at that video, that will assist you to know the theory, right? To gain to understand to have the full understanding of the theory, right? So here I wanted to have a look at the example, right? So they say the International Space Station, right, was launched in 20 November in 1998. It experiences an average net attraction force of 3.6 times 10 exponent 6 Newton. The mass of the International Space Station is 419,725 kg, right? So this is the scenario that you can see here. So basically the space station here, they are basically talking about the satellite, right? So they said this has the mass of 419,725 kg, right? So that's the first thing that we have to understand. And then now obviously the two objects, because you have to understand that the universal gravitational law is when we are looking at the mass of two bodies, right? So these two bodies that we are talking about is the mass, right, and the satellite. Okay, so sorry, not the mass, the earth is the earth and the satellite, right? So those are two bodies, right? So basically you know that the formula that you have to use is the F, which is the gravitational force, is equal to G, which is the universal gravitational constant, times the mass of the earth, right? Because we have two bodies, which is the earth and the satellite, times the mass of the satellite, divide by the radius, right? Which is between the earth and the satellite squared, right? But now the problem is that we don't have the mass of the earth, right? But we do have the mass of the satellite, but you don't have the mass of the earth. But don't worry, the mass of the earth and the radius of the earth, you can just go ahead and take that from your question paper, right? So that will be given to you. It's always given to you, right, in a question paper. In a question paper, the mass of the earth, right, is equal to 5.98 times 10 exponent 24 kg, right? So this is the mass of the earth, and the radius of the earth, which is something that you can also take it from the question paper, which is the radius of the earth is equal to 6.38 times 10 exponent 6 meters. Okay, so these two values you can just take it straight from the question paper, right? So it's something that you don't even need to memorize it, right? It will always be given. But the thing is, it is not given in this question because they are assuming that you know the mass of the earth and the radius of the earth, right? So now let's start by answering 6.1. So the 6.1, they say state the Newton's law of universal gravitation in weights. So the first thing that you should understand that all the time, if they want you to state the law, basically they will want you to use the same law to answer the following question, right? So it's very important for you to always understand the law, right? Once you understand the law, it will be quite easy for you to answer the following the question that follow after that. Okay, so because of the time, I won't just state it, I won't write it, but I'll just state it in weights, right? So 6.1, you have to know that the universal gravitational law states that every particle in a universe attracts every other particle, right, with a force, right, that is directly proportional to the product of the masses, Okay, so it basically it's directly proportional to the m1 times m2. In this case is directly proportional to the mass of the earth times the mass of the satellites, and inversely proportional to the square of distance between their centers, right? So the statement that said between their centers is very important. You will understand why I'm saying that statement is important. But I'm writing like this, mathematical, but we have to state it in words, right? So when you want to state, you have to write it, right? So when you're stating in words, you say every particle. You start by saying every particle in the universe attracts every other particle with the force that is directly proportional to the product of the masses and inversely proportional to the square of distance between their centers, right? So that is 6.1. Okay, so by the way, if you have any question, don't hesitate to go our comment section and leave a comment, right? And leave any question that you want to leave. I'll just attend you. I will just reply to you, right? And also I'm also available for the bookings, right? If you want to book me one-on-one session, you can book me, or if you want to have my group or my online group classes, you can also do that. Okay, but let's continue with the lesson. Right, so in 6.2, right, 6.2, let's do 6.2. So for 6.2 they say calculate calculate how many kilometers, right, that's the key, above the earth's surface the satellite is moving, right? If it experiences a force of 3.64 times 10 exponent 6 newton or on it in order to keep it in that specific orbit, right? So if they say calculate the height, right, if they say calculate how many kilometers above the earth's surface, right? So the earth's surface is this region, right? You can even call it is the circumference, okay? But that is the earth's surface, okay? So let me just redraw this for the sake of explanation. So this is the earth, right? And I will say this is right here as the satellite, right? Okay, bear my drawing. So my drawing is quite messy, but I hope you can see what I mean. Now remember, when you are stating the universal gravitational law, you say that the force is directly proportional to the product of the masses and inversely proportional to the square of distance between their centers. That means that if you want to get the distance, right, for this distance, which is this r, right, for you to get that distance you need to start from the center of each body, right? Hence you have to start from the center of this object, and also you have to start from the center of the earth, right? That is very important. But what they want the distance from the center of the satellite to the to the surface of the earth. So that is h, right? I'll call this is h, right? But now because I have to use the radius, right, I have to use the distance from the center to from the center of the first body to the center of another body, at this case from the center of the earth to the center of the satellite. Hence I also have to include this distance, right? And you have to note that this line is drawn from the center to the circumference or the surface of the earth. Hence that will be the radius of the earth. Okay, now if we write this equation, which is F equal to G times the mass of the earth, right, times the mass of the satellite divided by the radius of the between the earth and the satellite squared, right? This radius, right, this radius ES, right, will be equal to, this radius will be equal to RE plus H, because I want the distance from the center of the first body to the center of another body. Okay, now it's very important for you to understand that. So let's just go ahead and plug that in. So where there is ES, let me just replace that with the radius of the earth plus h. Now we want this h because we want the distance from the center of the satellite to the surface of the earth. Okay, so F equal to G ME, which is the mass of the earth, times the mass of the satellite, over RE plus H squared. You know, at this point you can just plug in the values, right? You can just plug in the values and get the final answer. But I would prefer to start by making H, which is the height that we want, be the subject of the formula, and then we plug in the values, right? I understand that you can plug in the values and find the answer by solving the equation while the values are already plugged, but I prefer making H be the subject of the formula, right? So if you do that, we can just do the cross multiplication, which will result you having something like this. So you'll have R, which is the radius of the earth, plus H squared equal to G ME times MS over F. Okay, over F. All right, and then now the next step, we have to find the square root on both sides. So I will have R, which is the radius of the earth, plus H, which is the height from the satellite to the surface of the earth, square root G ME times MS over F. Okay, and then now we'll take this RE, which is the radius of the earth, to the side. So we'll have H equal to square root G ME times MS over F, right? Minus, okay, minus RE, right? Now at this point I can just plug in the values, right? That is quite easy. And also you have to understand that G is the constant that is already given, right? So that is the universal gravitational constant, right? That you can quickly find it from the question paper. So let me just plug in the values. So G is 6.67 times 10 exponent negative 11, okay? And then ME, right, which is the mass of the earth, is 5.98 times 10 exponent 24, okay, kg. And then the mass that was given from the satellite is 419,725, okay, over the force, right? So the force that was given here, there is the force, okay? Okay, so there is the force. So the force is 3.64 times 10 exponent 6. Okay, so it's 3.64 times 10 exponent 6 minus the radius of the earth, right? So the radius of the earth is 6.38, right, times 10 exponent 6. Now let's just plug in the values now, right? Okay, so we'll start by solving the first part. Okay, so I'm punching the calculator here, so bear with me. Okay, so the first thing we will have 6.67 times 10 exponent 24, right, times 5.98 times 10 exponent, sorry, it was 6.67 times 10 exponent negative 11, okay, and then times 5.98 times 10 exponent 24 times 419,725. Okay, that is the answer. Divide that by 3.64 times 10 exponent 6. Okay, and then put that under the square root, and then I will have 6,781. Okay, and then subtract this 6.38 times 10 exponent 6, right? Subtract 6.308 times 10 exponent 6. All right, so we'll have 6,781 comma 7, I will say 80. Now this is meters. Now they want kilometers, so I have to divide this by 1,000. So if I'm dividing this by 1,000, right, so it's 6,781.80 divide by 1,000. So I will have 6.79 kilometers, right? So this is the final answer, right? So this is how you're going to solve this. And if you have any question, right, you can just go ahead and leave a comment. But don't forget to subscribe on my YouTube channel so that I can keep dropping this type of content. And also don't forget to book me. I'm also available on TikTok, right? If you can search 0 to 100 tutoring, you'll find me. And then you can also follow me on TikTok. I always drop also the few content there, right? But for now, bye bye for now, right? See you next time.